let's practice writing some exponential functions from a chart. We can use our exponential regression feature on our calculator to do this for us by plugging in the 2 points we're looking at, but we can also do it manually. So looking at this chart, what is the initial value C going to be? It is whatever the Y value is with the X value 0. So for this one, C is 500. The next part says use the points 3, 307.06, this other point here, to write the full equation. Round A to the nearest 2 decimal places. So we're going to write y equals C times A to the X and replace everything we know except for A. So the Y value of this point is 307.06. The C value, the initial value, is 500. We're trying to solve for A, and the X value that we're raising A to is the 3 that comes from the point above. We have the point 3 for X and 307.06 for Y. And we want to get A by itself. This is nice because we're solving for a base, not an exponent, so we don't have to use logs to get A by itself. We're going to use like a square root or a cube root button on our calculator to get A by itself instead. Well, first of all, it's multiplied by 500. So I'm going to start by dividing by 500 to get A by itself. So when I do that, I have 307.06 divided by 500, which gives me 0.61412. We bring this on up here. And that equals A cubed. So I need to take the cube root of that. I'm going to use the math button on my graphing calculator. And for me, I can choose between doing the cube root is in my math button and also doing the X root, which means switching any number on the root to what I want it to be. So I can choose maybe math 4 or math 3. I can figure out which one's going to give me the cube root of each side, so that I can get A by itself, and I'm going to plug in the cube root of 0.61412, which is going to give me to the second decimal place 0.85 for my A. And now I can do this last step of writing y equals C times A to the X, so y equals 500 times 0.85 to the X. So is this growth or decay? Well, you may have been able to tell by looking at it. We went from 500 to 307. So is that growth or is that decay? Well, it's definitely decay. Other way we can tell is A is 0.85, so it's less than 1. It's between 0 and 1, so it is decay. And we want to write it in percentage form. So the decay rate is going to be, well, it's going to be 1 minus 0.85. We can see how much less than 1 are we going to be, which is going to be 0.15, but we want it as a percent, so we're going to multiply that by 100. So when the factor is 0.85, that represents a 15% decay rate. Your factor is 0.85, and that represents a 15% decay rate. If your factor was 0.7, that would be a 30% decay rate. If it was 0.98, that would only represent a 2% decay rate. There is a pattern to these, but you can also work it out by doing 1 minus your factor for the decay rate, and then you just need to multiply it by 100 to make it a percent. I can also grab my calculator, and if I hit Stat and Edit, I can see what this equation would have been. By putting in for L1, I would do 0 and 3, just plugging in these 2 points that we made an equation for. And L2, I would put 500 and 307.06. Then I can hit Stat and go over to Calc and find exponential regression. And hit enter a bunch of times, and it should tell us this exact same equation that we just got. So we can do it with solving it ourselves, and then we can also check it in the calculator by just plugging in the 2 points to see if we modeled it correctly. By hitting Stat, Calc, and finding exponential regression if we scroll down.